Hello everyone, welcome to all of you. As we know very well, here we are going to discuss the excellent practice questions from the permutation and combination. So let's have a more discussion on the permutation and combination questions. In the last session also we had a discussion on the PNC, permutation and combination questions. So let's continue with that one. So in the last session I gave you this question as a homework bachcho. I hope you guys tried, and if you tried, then what is your result you can write down in the comment box. So let me read the question for you. If the letters of the word Verma, V-E-R-M-A, are arranged in all possible ways and these words are written out as in a dictionary, so when the rank of the word Verma is, so what is the rank of the word Verma, we need to find out here. So how to approach, dear students? How to approach? First of all, please confirm about the audio video, whether is it clear or not. Yes. All right. So here let's approach with the question. So this is a good question, how to approach, as it is mentioned to us what is the word. So let's start with the word V-E-R-M-A. Now what to do? Now what we will do, we will just arrange first of all the letters alphabetically. So first of all we will arrange the letters alphabetically. So when I will go with the alphabets now, so what I will write down, I will write down first of all A will come here, then after that E will come here. So you need to be careful, dear students, while approaching this one now. You need to be careful because the requirement of the question we need to satisfy. So if the question is asking about, that we need to go with the alphabetical arrangement, so we will go with the alphabetical only. Okay, yes. So A, E, then I will go with M, then I will go with R, and then at the last V will come. So here when I will approach A, E, we are having, is it connection is proper or not? Okay. So here when I will go with this one, so A, E, M, R, V we are having. So what I will do, when I will arrange this one, I need to arrange all these letters and I need to make again the letter Verma. So when I will start making, my first approach will be, my first word will be start from, as we are having 1, 2, 3, 4, 5 letters here. So 1, 2, 3, 4 and 5 will be here. So when I will go alphabetically, my first letter will be start from the A, because alphabetically it will start from A. So here we can lock the A. Now do we need the word starting from A? No. What is our requirement? We need, or we require the word which start from the V. Okay, so until and unless we are not getting V, we will just go with the first letter. So when I will go with the alphabetically, first of all A will come. So in the starting I can fix the A. Now on the remaining 4 places, any 4 of the letters can be there. So for the arrangement it will be 4P, 4 means the 4 factorial. When I will go with the second one now, again I will go with the alphabetically. After this 1, 2, 3, 4, 5 we are having, E will come. Again for E we are having, we can fix the E because we don't want the letter, the word which starts from the E. We want that our word Verma will start from the V. So that's why here also I will do the same thing. Here we are having the 4 places. If I will fix E here, so when I will fix the all 4, yes, okay, when I will fix all the remaining 4 places, it will be 4 factorial. Okay, and here when I will go for the next, it will be start from M, 1, 2, 3, 4. So when you are fixing M for the remaining 4 places, it will be 4 factorial again. When you will go for the next R, okay, this also we don't want 1, 2, 3, 4. So it will be again 4 factorial. And when I will go with the next one, fifth one is what? V. So now we required this one. So 1, 2, 3, 4 and 5. We required this one. So now we will not directly go with the V. So this is just like this now. When you are opening the dictionary, suppose you want the word starting from ver, so what you will do now, you will just open your dictionary book. Okay, you will start just skipping the words, skipping the words which start from the letter A, B, C, D up to V. When you will enter in the segment of V, what you will do now, you will just search there, because you want VE. First of all, it will be VA, but we don't want that one, so we will skip again that one. We required VE. So the same pattern we will follow here, because once my first place is done with the alphabetically, now when I will go for the second place, now I can see the second place, on the second place the first letter will be A. So but I don't want A. Okay, I don't want A, so I will not go with this one. So but here I can see 1, 2, 3 places we are having, so it will be 3 factorial. When I will go with the next one, so next one will be, we are having V, and here 1, 2, 3, 4, 5. So A is already done. Now the next will be E. Okay, we want VER, right? We want VER, but when I will go with alphabetically now, so it will be A. Okay, because when I will go, E is already done. So when I will go with alphabetically, again A will come, then M will come, then R will come. So it will be the only one possibility. So it will be 1. When I will go for the next case, beta, 1, 2, 3, 4, 5. So here it will be V and E is already fixed. Now what I am fixing? I am fixing V and E here. Earlier we stuck with the, earlier we fixed V. Okay, now we are going with V and E. So when we are fixing V and E, when I will go with alphabetically, A, M, R is already done. We already approached that one. So when we will go with the next one, it will be A. Okay, after E, V and E, as I already fixed. After that A will be there, R will be there, or M will be there. So what is the next possibility? R and M. These two we can interchange. Yes, these two we can interchange. Okay, A, R, M. Now the next is again possible when I will go with VEA, 1, 2, 3, 4, 5. VEA. Okay, now the A is already completed now. So at the third position, when I will come with the next one, as V is already locked, A is done. So now when we will come to the next one, it will be M, R and V. Okay, first case is this one, M, R and V. Sorry, V is already completed. M, R and A. M, R and A. Okay, and here not M, R and A. M, A and R, because alphabetically when I will go now, so it will be M, A and R. Okay, and when I will go with, this is the 6th, 7th, 8th. When I will go with the case number 9, so here we will go with VE, and now VE, M, A, R we already make. So now we will go with M, R, A. These two can interchange. M, R, A, 1, 2, 3, 4 and 5. Okay, and now 2 more efforts are required, and then we will get the required result. So when I will go with next one, 1, 2, 3, 4 and 5, it will be VE is there. Now the third position, M is already done, third position A is already done. So M done, A done. Now I will go for the next one will be R. Okay, and after that when I will go alphabetically, it will be A and M, but I don't want A and M, I want M and A. So at the next position I will get VER, MA, because these two can interchange. So here how many means steps we required, or I can see that I need the rank of this word in the dictionary. So I can see 1, 2, 3, 4. 4 factorial is already 4 times. So 4 factorial into 4. Okay, plus 3 factorial plus 1, 1, 1, 1, 1, 1. 1 is coming 6 times. You can see 3 and 3, 6. So the total number or the dictionary number will be 4 factorial multiply with 4 plus 3 factorial or plus 6. This will be your position. 4 factorial multiply with 4 plus 3 factorial plus 6. 4 factorial is 24. 24 into 4 will be 96 plus 3 factorial is 6. again 6. So 96 plus 12 when you will go, so it will be 8, it will be at 108 position. So what is the position it will have bachcho? It will have 108 position, or the rank of the letter will be what? 108. Okay, so rank of the letter will be 108. So in this way we can approach it very easily, we can approach, but still, as we already discussed, these type of questions are quite lengthy, because we don't have any shortcut for these type of questions. If means it's very simple task. If I will tell you beta ki just go for the word which start from the W in the dictionary, then what you need to do, you need to go up to the W na, you need to flip your pages na of dictionary. So when you will go up to the W, it will take time definitely. So this is the same process here. So if we need, so my result is 108, here the option A. If we need the rank when we are switching, or when we are flipping the alphabetically, so it will be 108. All right, now let's come to the next question. So this is a good question. This question also I give you as a homework. Let's have a discussion. So now the question is, in how many ways can a committee of 4 women and 5 men be chosen from 9 women and 7 men if Mr. A refuses to serve on the committee if Miss B is member? So this is again a good pattern of question. What is the mean? This is just like a condition is given here. What? Ki you need to choose a committee of how many persons? You need to choose a committee of 4 women and 5 men out of the 9 women and 7 men. We need to choose a committee of 4 women and 5 men out of the available 9 women and 7 men. But what is the condition? There are 2 persons, Mr. A and Miss B. If Mr. A will be there in this committee, then Miss B refuses to work with Mr. A. So this is the special condition given to us. Okay. So this similar pattern of question we already had a discussion in our classroom also, bachcho. So let's have a look how to approach. Had you tried this question? If yes, then you can write down. If no, then let's have a discussion. So what are the possibility? So first of all, I can see there are 9 women and 7 men. Okay ji, 9 women and 7 men are here, and after that we need to make a committee of 4 women and 5 men. Okay, we need to make a committee of 4 women and 5 men. All right. So what I will do, I will just take the cases. First case is what? First case when Mr. A is in the committee. Obviously there are few cases will be possible. So my first case is when Mr. A is in committee. Okay, or Mr. A is selected. Suppose when Mr. A is selected, I need to make a committee of 4 women and 5 men. So what I can see now, when Mr. A is there, so already 1 man you already selected, so Mr. A is there. You need to select 5 men. Out of the 5 men, you need to select 5 men. Out of the 5 men, already 1 is selected. Now you need to select only 4. So what you will do now the available persons or available men are also 6, because 1 is already fixed. So this position we already fixed. What I will do, I will just go for the 6 men. Out of the available 6 men, I will select any 4. Out of the available 6 men, any 4 can be there. Okay, and as we know very well, if Mr. A is there in the committee, so Miss B will not be there for the, Miss B will even not available for the selection. So when Miss B is not there or not available for the selection, what happened? When Miss B is not available for the selection, so what happened, bachcho? Here we can directly approach now. When Miss B is not available, so now we are having only 3 women. Out of the 3, now we are having only 8 women. Out of the 8 women, I need to select 4, because 1 is already denied. Earlier I was having 9 women. But as Miss A already denied, because you selected in the committee, or in the committee Mr. A is already there, so Miss B will not be there. when Miss B is not available for the selection, so now we are having only 8 women. Out of these 8 women, we need to make a committee of 4 women. So I need to select 4 women. It will be 8C4, right? So this will be my very first approach. So this will be 8C4, and here we are having 7 was earlier. So 1 is already selected, or you can write down 1 is already selected na. So it will be 6C4. 1 is already selected, so it will be 6C4. All right. Okay. So this is the first possible case. Now, okay, Mr. A refuses. Wait a minute. No, we cannot take this one, because now here the case is opposite. No, here B is not refusing, A is refusing. Please read the question again, because now this is the important line. This is the important line. What is given here, bachcho? Just read it. Mr. A refuses to serve on the committee if Miss B is the member. So if I will make now that Mr. A refuses, so I need to go first of all for the selection of Miss B. So the first case here, although we will take the same, but here as I need to make the selection of 4 women and 5 men now, what I will do, out of this one, if you are selecting Miss B, so suppose you are selecting Miss B is already selected. So when Miss B is already selected, you need to make a group, or you need to make a committee of 4 women. So now what? Now available women are only 3. Okay, and here also the 1 is remaining. So means 1 is already selected. So here we can go with, for the woman it is 8C3. When I will go for the man as Mr. A will now not available, because it is given na Mr. A refuses to serve. It's not that each other. The question which we discussed earlier, where we had a discussion that X and Y don't want to work together. So they don't want, means if X is there, then Y will be not there. If Y will be there, then X will be not there. So but here it's a simple case when Mr. A refuses to work, okay, when Miss B is there. So when Miss B is there, so it will be, we are having available persons now 6 only for the man, because Mr. A will be not available now. So here it will be, out of the 6 men, we need to make a committee of 5. So it will be 6C5. It will be, bacho, what? 6C5. Okay. Very easily we can get this result. Yes. Do reply. Yeah. Okay. So this is the first case which is possible. 8C3, and we can go with the next one is 6C5. So if you want to solve, you can solve. So the possible case will be 8C3 and 6C5. So 8C3 you can open as 8 into 7 into 6 by 3 into 2. Multiply 6C5 is 6C1. But directly we can write down 6, and here the 6 and 6 will be gone. So when you will solve here 8 into 7 into 6, it will give you 336. It will give you 336 first thing. Now this is my first case, so I am writing here the case number 1. Let's come to the case number 2. Only 2 cases are possible. Now when the Miss B is in the committee, and second when Miss B is not in the committee, only 2 cases are possible. When Miss B is in the committee, then Mr. A refuses to work, which we already had a discussion. Now let's come to the second case, when Miss B is not there in the committee, then definitely Mr. A will be there in the committee. So here when Miss B is not selected or not selected, okay, so I need to go with the base of Miss B. Miss B is not selected. Okay, so when Miss B is not selected, so here I need to make a committee of 4 women and 5 men. Out of that, you can say that now the available women are again 8, because Miss B is not selected. So out of the available 8 women, you need to select 4. So the required number of way will be 8C4 for the women's. And when we are talking about the man, as here Mr. A is already there, right? Mr. A is already there, so there is no need for the selection. So here we can go with, now we are having available men for the selection are 7. Out of these 7 we need to select 5. So it will be what? It will be 7C5. So 8C4 multiply with the 7C5. When you will solve 8 into 7 into 6 into 4 by 3, 4, sorry, 5, 4, 3, 2 and 1, and here 7C5 is 7C2. So 7 into 6 by 2. When you will just solve this one, it will be 3 2 ja 6 and 6 gone, 4 2 ja 8, 2 and 2 will be got. So when I will solve 7 into 7, okay, 30 and we are having 49. So when I will just solve, this will be 1470. This will be, let me cross check, this will be 1470. Okay, and we need to find out the total value. So it will be yeah, and here we are having 336. So the total or the required number of ways will be, total required number of ways will be 336 plus 1470. 336 plus 1470. When you will solve, the result will be 1806. 1806 will be your final answer. When you will go here, we are having options surely. So my answer will be here D for Delhi. I can see my answer will be here what? D for Delhi. Yes. Very easily we can approach it. Alright guys. Now, so these two questions which I give you already as a homework. Now let's come to the next question. Next question is how many different, this is a good question, how many different 8-digit numbers can be formed using only 4 digits 1, 2, 3, 4 such that the digit 2 occurs twice. You can repeat 2 times, otherwise all numbers should come once only, and you need to make 8-digit number using these. Okay, so go for it. Go for it, bacho. You will try, we will have a detailed discussion. How many different type of different 8 digits number can be formed using only 4 digits? Okay, using only 4 digits 1, 2, 3, 4 such that the digit 2 occurs twice. So it's mentioned clearly that the digit 2 occurs twice. So when 2 occurs twice, it will be 4 plus 2, 6. So one more you can repeat, but it's not mentioned, but clearly mentioned that the 2 occurs twice exactly. Yes, go for it, bacho. Now let's approach it, bacho. Let's approach it. How many different 8-digit numbers? Now let's have a discussion. So you are asking about different 8 digits number na. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, as it is mentioned that the using 4 digits, where digits we are having 1, 2, 3 and 4. using these 4 digits, I need to make I need to make 8 digit numbers, okay, different 8 digit number. But what is the condition given to me such that the digit 2 occurs twice, and it is clearly mentioned that the digit 2 occurs twice. Okay, now what I can do now, for other it is not mentioned, but for 2 when it is mentioned, so what we will do, first of all we will start from that condition only which is given to you, that the 2 occurs twice. So we will write down here digit 2 can be arranged. How it will be arranged? So digit 2 can be arranged in 2 places. Okay, I can write down here 2 can be arranged in 2 places. Here it can be any among these 8, 2 places among the available 8 places, right? So 2 places among the available or out of the 8 places, out of the available 8 places. So it will be, we are having 1 2 3 4 5 6 7 8. So out of these 8 I can just arrange these 2 digits anywhere. So 8p2 divided by, because the 2 is repeating itself, so divided by 2 factorial. 2 is repeating itself, that's why yes. So what happened here, we can see now 8p2 by 2 factorial. Why I write down here 2 factorial? Just because the 2 is repeating 2 times. So we know very well, whenever any number, any digit is repeating itself, so the number of time it is repeating, we need to divide by that factorial. So if my 2 is repeating 2 times, I am going here with the 2 factorial. It's very simple. Okay, now this is the arrangement of 2 places. What about the remaining 6? So suppose the remaining 6, if we are having, suppose anywhere, okay, it's not necessary that these 2 or these 4, it can be anywhere. So now we can write down for the remaining 6 places, bachon. For the remaining 6 places, the number of arrangement will be, because now we are having only 3 digits, whether it is 3, 4 or 1. For the remaining places, we are having only 3 digits. So it can be anything. It can be anything. It can be here. Okay. It can be here. It can be here. It can be here. So it will be 3 power 6. So arrangement for the remaining 6 places will be 3 power 6. Why? Because now we are having only 3 digits remaining, okay, and we are having 6 places, so it will be 3 power 6. 3 3 3 3 anywhere, means among these 3 any one is possible. Okay, so that's why it is 3 power 6. So now the final required number of ways, or the total required number of ways, is we need to arrange the two numbers, means the number 2 also 2 times and the remaining 6 digits also. So it will be 8p2 divided by 2 factorial multiplied by 3 power 6. If you know one basic concept here, you can directly solve. What if you know, bachon, that actually what is the relation between permutation and combination? If you want to approach na, NPR by R factorial is nothing but NCR. This is the relation between permutation and combination. Means you can write down rather using this one permutation, I can go with NCR multiply with R factorial. Okay, so here I can see that NPR by R factorial I am having. So at this place I will go directly with NCR. So I will use here 8C2 multiply by 3 power 6. 8C2 we can open as 8 into 7 by 2 means 4 7 ja 28. So here it will be 28 into 3 power 6. When you will open, do we have options here? Yeah. So when you will open, you will get the result 20412. When we will open now, when we will just solve this one, we will get the result as 20412. This is the final answer. 20412 will be your final answer. So very easily we can approach it. Now the only condition which you need to understand here, that in this case now, the specific condition is given to you that the digit 2 must be repeated 2 times. Okay, so this is the thing which we need to carry forward with this question. So 8p2 by 2 factorial is an important thing. Otherwise, now we are having remaining 3 digits and the places are 6. So it will be 3 power 6, simple permutation, simple arrangement. And then when you will solve overall, here we can use, either you can solve 8p2 separately, by then you can go with the 2 factorial, or if you don't want to follow, you can use this relation between permutation and combination and you can solve it. Okay, now let's go with the next question. Find the number of numbers that can be formed using all the digits 1 2 4 1 2 3 4 3 2 1 only once, so that the odd digits occupy odd places and automatically even digits occupy even places. So we need to find out how many numbers will be there when I will go with the digits 1 2 3 4 3 2 1. Okay, and only once, we will not repeat other than this. The number are already written, we will not repeat other than the numbers. And the odd digit, this is the key point, or this is the important point mentioned in this question, that the odd digits occupy odd places only. So guys, just go for it. A very good question. These pattern of questions surely we can expect, okay, in the good exam, just like the GATE. So you should not miss this one. Go for it, everyone. Yes, dear students, just try this one. Yes, now let's approach it. So a simple question we are having, how many digits we are having? Let's write down 1 2 3 4 3 2 1. So these are the digits given to you, 1 2 3 4 3 2 1. Okay, so we are having 3 and 3 6 and 1 7 digits. Okay, we cannot repeat any one. What is the condition given to you? Odd digits occupy the odd places. So first of all, 1 2 3 4 5 6 7. So when we cannot repeat any digit, it means we need to make a 7 digit number only, right here. So odd places, this is the odd place, first, third, fifth and seventh. So these places occupied by the odd digits. Which digits we are having as a odd? So odd digits are 1 1 3 3. we are having 2 times 1, we are having 2 times 3. So these are the odd digits which will be occupied at the odd places. Okay, when you will solve this one, so here we can see, ma'am, we are having 4 digits and 4 okay, how many odd places we are having? We are having 4 places odd, and we are having 4 digits also as a odd. So it will be directly, we can go with the 4p4, 4 places, 4 elements, 4p4 divided by 1 is repeating 2 times, so 2 factorial. 3 is also repeating 2 times, so this is again 2 factorial. 4p4 is nothing but 4 factorial. It will be 2 into 2. You can solve like this one, 4 into 3 into 2, or you can directly write down 24 by 4. 4 and 4 will be gone. So here in the first case, number of ways are 6. In the first case, number of ways are, dear students, what? 6. Okay. Now let's go with the second. This is for the odd digits only. So I will not only have the arrangement, or not I will not only do the arrangement of odd digits, as it is clearly mentioned, when the odd places occupy the odd digits, I need to find out the numbers. Okay, how many numbers are possible in this case? So the automatically the remaining places will be occupied by the even digits. So it will be even number, even number, even number. So let's see the arrangement of even numbers also. When I will go with the even number or the even digits, here I am having 2, 4 and 2 as an even digits here. So 2, 2 and 4 are your even digits. We are having 3 places, yes. We are having 3 digits, yes. So it will be 3p3 divided by 2 factorial. Okay, and we are having only the digit 2 which is repeating 2 times. So divided by 2 factorial. So 3p3 is nothing but 3 factorial divided by 2 factorial. This actually 2 factorial will be gone, but still you can write down like this one. Your result is 3. So this is possible with how many number of ways? 3 number of ways. So the odd digits occupy at odd places by 6 number of ways. The remaining even digits occupy at the even places by the 3 number of ways. So the total number of ways will be, now there are so many students, what they will do now, they will do like this one, ma'am, 6 plus 3, 9, and they will be very happy that we are doing right. No, this is absolutely wrong. Absolutely wrong. 9 will be not there. Why? Because I need, when we are putting plus, okay, just try to understand this thing. When we are putting plus in between any 2 events now, here the meaning of plus in the probability and permutation and combination is either this is possible or this is possible. I am asking about the options. So either this one is possible or this one is possible. So here if I will put the plus between 6 and 3 now, so what is the sense of this question? That either odd places occupied by the odd digits, or means English or of English, or okay, or the even places occupied by the even digits, but this is not correct. Why? Because I need to make a complete digit or complete number where odd places occupied by the odd digits and even places occupied by the even digits. So my requirement is and, not or. So that's why I will not use here multiplication, addition. It will be multiply 6 into 3. So my final result will be 6 3 ja 18. So what is the correct answer? 18. How many ways are possible in this case? So possible ways are 18, which you can see in option C for Chennai. Which you can see in option C for Chennai very easily, bachcho. Right? So I hope you are getting my point. Like this now we need to approach. Otherwise, if you will go directly, it will not work. It will not at all work when you will go directly. Okay? Now, let's come to the next question what we are having. Let's come to the next question. So again, this is a good question. These type of questions now are definitely important for the GATE exam also, and even for all the other technical exam which you are going to appear, either that is any PSU exam or even your campus recruitment test. This is important surely. Now let's come to the next question. This is a question with a simple twist. So NC3 is 2. the question comes with the permutation or the combination including ratio. So NC3 is to n minus 1, C4 is equals to 8 is to 5. Then find the value of n. You need to find out here the value of n bachcho. How to find out the value of n? Let's go for it. How to find out the value of n? Just go for it. A simple question. If you can understand the sense, you can very easily approach this one. Yes, everybody, just go for it. Yes, guys, had you tried? If tried, then what is the result? Just tell me, प्यारे बच्चों. If you tried, then what is the result? What is the result in this case? Is it 18? Okay, for the previous one you replied as an 18. Let's approach it. Let's approach it. So a good question. Let's go with this one. So first of all, do you know how to open NCR? Because here you need to use this one. NCR is nothing but n factorial by n minus r factorial, okay, multiply with r factorial. In this way we can open. So what is given to you? We are having the two ratios which is equals to 8 is to 5. So this is given to you NC3 by n minus 1 C4 which is equals to 8 by 5. Now let's use this one. First of all, I will open NC3. When I will open, this will be n factorial by n minus 3 factorial multiply by 3 factorial. Okay, yeah. Saksham is there with the answer. N is equals to 8. Shabash, very good, absolutely right. Okay, and if I want to open n minus 1 C4, it will be n minus 1 factorial divided by, now be careful here, I need to go with n minus r. So n minus 1 minus 4, and here it will be 4 factorial. So it will become n minus 1 factorial by n minus 5 factorial multiply by 4 factorial. So now let's use the ratio given here. So when I will use here, it will become n factorial by n minus 3 factorial multiply by 3 factorial. Overall, n minus 1 factorial divided by n minus 5 factorial multiply by 4 factorial, which is equals to 8 by 5. Okay. Now let's go for the simplification. So here, as we are having n factorial, now when I will just take n common, I will take, means when I will take n outside, it will be n by n minus 1. I am having n minus 3 also, so let it be n minus 3. Okay, when I will take n minus 3 outside, it will be n minus 4. When I will take n minus 4 outside, it will be n minus 5 inside now. So here I can write down n minus 3 and n minus 4. In the bracket, inside the bracket, we will have n minus 5 factorial multiply by 1 by 3 factorial multiply by, now this I will take as an there, n minus 5 factorial 4 factorial divided by n minus 1 factorial. So now this n minus 1 will be gone. This n minus 5 will be gone. Okay. So now we are having 4. Even if you want, you can just take 4 and 3 factorial. So this 3 factorial will also gone. So now what we are having, we can write down directly what we are having, n into 4 divided by n minus 3, n minus 4, okay, and it is equals to the ratio 8 by 5. Okay, this we are having now. This we are having now. So if you want, then you can just consider here 4 2 ja 8, because this is equals to 8 by 5 na. So you can cancel out this one and you can equate it equals to 2 by 5. So I can equate this one as 2 by 5. So I am having n minus 3, n minus 4. So it will be 5n equals to 2 into n square, when I will open n square, minus 4n minus 3n plus 12. Okay, and here when you will just solve this one now, so this is 5n 2n square minus 7n. So I am opening directly 2n square minus 7 2 ja 14n plus 24. And when you will open this one, it will become a quadratic equation. 14 we are having, and when it will be there, so minus 14 and minus 9 minus 5, so it will be minus 19n plus 24 is equals to 0. When you will just solve this one now, we are having the two values of n. We will get the two values of n when we will solve. This will be n minus 8 and 2n minus 3 equals to 0 will be the factors. N minus 8 and 2n minus 3 is equals to 0, as my n cannot be a fractional value, because n is the total number na, so number cannot be fractional value. So here when you will write down 2n minus 3, so it cannot be the root, because n cannot be a fractional value. So directly you can write down from here that n minus 8 is equals to 0. So your n will be what, dear students? 8. Your n will be what? 8. We don't have option here, so your result will be n is equals to 8. Directly we can conclude that n is equals to what? 8. Right? Very, very easily we can approach this one. Very, very easily we can approach this one. Clear? Okay. Now, let's come to the, this is a good question. Now, let's come to the last question of permutation and combination. So after this, we already discussed few questions in the last session, now few here. So many variety of question we discussed in the permutation and combination. So this is the last question of today's session. In how many ways a cricketer can make a century with fours and sixes only? So now this is clearly mentioned, and I hope everyone can approach this one, that how a cricketer can make century with fours and sixes only. How many number of ways are possible? How many number of ways are possible? Even if you are having doubt, you can make one by one cases. You can make all the one by one cases here. Yes, what should be that? In how many ways a cricketer can make a century with fours and sixes only? How many possible ways are there? 6, 9, 8 or 10? Yes, bachcho, tell me what is the result? what is the possible approach? In how many ways a cricketer can make a century with fours and sixes only? You should reply. You should approach this one very easily. Everyone can approach. Okay, so you want that century. Century means total 100. Okay, we want total as 100. So what are the possible ways? So when I will I need to calculate here one by one. So when I will go with the first one, it is possible when we will go with the 25. If a cricketer just made 25 fours, so then also the 100 will be there. Okay, so this is the first possible way. Or other, suppose he approached 22 fours plus 2 sixes. 22 4 plus 2 sixes, the total is 100 here. Here also the total is 100, right? Okay, so 22 fours or 2 sixes. Or it is possible to go with the, if I want to decrease the number of fours, so it will be 19, because as we can see now, you approach with the 0 6. Okay, 1 6 is not possible, because when you will go with the 1 6 now, then the number of fours will not be arranged, because we need to make the total as 100. Okay, so either 100 will be made by 25 fours, or 100 will be made by 22 into 4, which is 40. When I will go this one, which is 48, and here I can approach. Okay, so please be careful. This is 22 into 4, 88, and plus 12. When I will go with this one now, so be specific. We need to calculate overall. We need, the requirement is 100 only. So when I will go here, so it will be 19 fours are possible, and the number of sixes you can increase. So it will also increase in the, okay, the number of 4 will be in the odd numbers, and here the number of sixes will be in the even. So once it is 2, now it will be 4. So this is 24, and when you will add, total is again 100. So it is giving you 100. Or if you will go with the next one, what is the possible? 16 is there. So 16 fours plus 6 sixes is also possible, right? 36 plus 64. Again you are having the total as 100. If you want to go with the next one, so it will be 13. We can see the difference is 25 minus 3, 22. 22 minus 3, 19 minus 3, 16 minus 3. So I am going with the 3 difference, and here I am starting with the 0, 2, 4, 6, and it will be 8. So 8 sixes will be there, then also the 100. If I will go with the 10 4 means 40, and 10 sixes 60, again it will be 100, right? Now, or more also we can go with the, after 10 it is possible 7 fours or 12 sixes, then also it will become 100. Or when I will decrease again, so it will be 4 fours and 15 sixes, then also it will become 100, right? And the last, when it will comes with the 1 4 and 15 will be there, so it will be 18 sixes. 18 sixes. Okay, so if I will go with this one, 18, no, it's my mistake. We are increasing now, so this will be 14, and now this will be 16 sixes, not 18. Okay, 96 plus 400. Yeah, so then also the 100 is possible. 96 plus 4, then also the 100 is possible. Here also the 100 is possible. So I can see we are following a simple pattern, that your number of fours are decreasing by 3, 3, 3, 3, 3. Number of 6 are increasing by 2, 2, 2, 2, 2. So when you are going with the last one, this is the last possible case. So how many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many possible cases? In this way, 9 cases are possible. So here we need to approach directly. How many possibilities are there? 9 cases are possible. So in this way we can approach it, but so very easily, very simply. Okay, sometimes we need to use the basic sense also, rather going with the formula. When we will follow this one, we can very easily approach this one. Okay, so ultimately you can see that here the selection of 4s and 6s is only. So how many 4s and 6s you need to select for making 100? So that you need to check here that the maximum 25 are here, and here the maximum is 16 6s. Okay. Alright, so I hope this is clear to everyone. That's all from this session. We will meet again with the next topic. So if you are preparing for the GATE exam, stay connected to this YouTube channel, because here we are covering lots of things for you dear students, which are in the form of concepts, which are in the form of the excellent practice questions. So you should not miss this one. Okay guys, stay connected to IIMS GATE Academy YouTube channel. Bye bye, take care, good night. Thank you.